All right, so it is Tuesday, March 7th, and it is 7 o'clock, and so it is time for us to get going. So we're going to do a look at activity, but we're going to hold on the look at activity until we get a few more people to drop in here. So I'll start with this. So let's take a look at our syllabus, and the time is flying by. So we are 5 weeks into the course now, starting week number 5, and that is the work that we just had done. So for this week, this is where our focus is going to be. And again, there's a reason that we're only looking at really one sort of programming type thing, one Python application, and then we have the discussion question. The reason for that is so that you guys can fully focus on Lab 492. And so we're going to be talking about Lab 492 tonight. And that's basically going to be us creating a Python application that's going to be the client application that's going to interface with the MapQuest API server. And so we'll be taking a look at the developer.mapquest site. We're going to be looking at how to generate your token so that you can make requests to MapQuest. So it's actually a really, really cool application. So this is kind of where the level of difficulty is going to start to increase a little bit with respect to APIs and using APIs. And the good news is that after Module 4, you guys will get what I consider to be a huge break in the course. And that is because we'll be doing Module 5. And Module 5 is all review. And it's very, very simple networking review. So Module 5 is kind of a significant break before we jump right back in to some Python work with Docker containers. And again, everything we're going to be dealing with from here on out is really, really good stuff. So this is what we've got for this week. You've got the Module 4 discussion on Git libraries, JSON, XML, YAML, and more. And then we've got the 492 integrate a REST API in a Python application. So basically what we're making is we're making an API client as opposed to an API server. All right, so any questions on that, on where we're at? And the grading is all done. I'm still doing some 357 labs, so I'll be making my way through those. But other than that, everything else should be entered and up to date. If you're missing anything, please make sure that you let me know. All right, so we're talking about module number 4. And so module number 4 starts out talking about the different kinds of APIs and what APIs are. And the key takeaway is that the API is there. And I want you to think of the API as like, a supermarket of sorts. And you can interface with that supermarket to get different things from the supermarket. The example that they give you in the book is it's like an electrical outlet. And that's a great example too, great analogy as well, where an API like MapQuest's API allows different clients, a Python script, I could use a Java script, I could use Postman. We're going to see Postman tonight, and Postman's a very, very, very cool application. Here's Postman right here, and I've got some GET requests that we'll be taking a look at. So, but the client, right, just like you can plug different things into the electrical outlet. I can plug my iMac in. I can plug a light in, right? I can plug my phone charger in. And so the electrical outlet or the socket would be like the API server. And all these different applications or different appliances can plug into the wall outlet and use its power, right? And so the API is kind of the same way. So you've got this API, and again, I'll be mentioning MapQuest a lot tonight because that's going to be relevant with what we're going to be working on. So you have these API servers like MapQuest, and then you've got Google Maps, and then you've got Yahoo has an API server. And so the MapQuest API server allows us to use whatever client it is we're using, whether it's a Python script or a JavaScript or Postman, to make queries, right, like GET requests to try to get information from MapQuest. And so typically when we're talking about the APIs, it's usually machine-to-machine communication that's taking place, right? And in this case, it's our client application and the API server that MapQuest has. Now, the chapter opened up and it talks about two different kinds of APIs. It talks about synchronous APIs, and then it talks about asynchronous APIs. So the synchronous API, one of the key takeaways there is theoretically, all things being equal, it's faster than an asynchronous API. And so synchronous API would be responding instantaneously to the request, whereas an asynchronous API, you send the request in, the server gets it, and then it's got to do some type of, machination over the data or whatever the case may be to produce the response for you, right? So you've got synchronous APIs, asynchronous APIs, and the synchronous APIs are considered to be a little bit quicker. With what we're doing, I mean, you can see that, you're making requests and it's taking less than a second, right? So this one here was 744 milliseconds. So it's less than a second. So that's pretty quick, right? That's pretty quick. Now, the GET request or the API requests that we're making are actually pretty straightforward and pretty simple. So they're actually going to be taking place rather quickly. All right. So that's how the chapter opened up. And then it talked about the API architectural styles. And so there's three basic styles that they talk about. They talk about RPC, which stands for Remote Procedure Call, and that has been around forever. I was using RPC calls back in the early 90s with something that a product Sun Microsystems had called NIS, Network Information Service, or NIS Plus as well. And so that used RPC calls way back in the day. So RPC has been around forever. And then you have SOAP. And SOAP is one of those things that the chapter, it talks about SOAP. Know that SOAP is a Microsoft invention. And but that's really all we do with SOAP. There's not much need for us to use SOAP. And then it talks about REST, right? And that's the representational state transfer. And so REST is really the big dog in the room in terms of what's being used with network programmability today. Sure, RPC is out there and SOAP is out there, but REST APIs are really sort of taking over a dominant share of the APIs that are out there because it's so simple. And while it might not seem that way initially when you're first learning about REST and how we interface with REST APIs, the reason that it's so simple is because it's based on HTTP, right? It's based on what we use to view web pages, right? So when you go to www.netacad.com, that's just an HTTP GET request, and it happens to be RESTful, right? And it's RESTful because it meets those criteria that REST requests need to meet. And so one of them is, and let me go down through them in order here. So one of them is, and I want to do it in order, but it's not cooperating here. And that's funny. I have my little list here and it's not popping up. So it talks about the client server model, right? So you've got a client, and that can be whatever the application is, like Postman, and then you've got your server. So there's certain criteria. There's 6 criteria that the book mentions. And this might be a good time to take a look at the actual dissertation that was done that sort of created the RESTful architecture. And it's just by this gentleman here, and I can't remember his exact name. It's up at the very, very top. I thought it was at the very, very top. But this is part of his dissertation. He was a U.S. computer science. Oh, wait, you know what? It only went to 5. Here, hold on. Let's go to the very, very top. And yeah, Roy Thomas Fielding, right? And in chapter 5 of his dissertation, he talks about REST. And you can see here, deriving REST, the architectural elements of REST. And so this was really what outlined the REST architecture. So REST and RESTful It's super simple, right? REST is this framework that's used to exchange requests on the internet, right? It's what HTTP uses. RESTful is just simply how you refer to something that meets the requirements of the REST framework. So if it meets certain requirements within the REST framework, then it's considered to be RESTful. And so what are some of those requirements? So you come down here and they've got like this little diagram here. This was before graphics were a thing on the internet. And so let's scroll down a little bit further. All right. So it didn't list out the representations. I'm trying to find out where it had the list. And I guess we could flip back over here. And I do have, at least I believe I have, up here, and it should be under instructions, requests. Yeah, so here we go. So we can look at it from this perspective here. So client server, right? That's the first one I had mentioned. So it needs to be stateless. And what that means is that the server is going to respond back with whatever it is that you requested, right? Your directions via the MapQuest API, and then that's it. Then there's no state information that the server's keeping, right? The server's not keeping track of the conversation that's going between the client and the server. Server gets a request, server replies to the request, that's it, server's done. And then you've got cache, right? And this is going to be something you would find in one of the headers as to whether or not the information could be cached by the client to be used again. You've got a uniform interface. That way, all of the clients are interacting with the server in the same way. Then you've got a layered system, and then the optional one is the code on demand. And so those 6 categories right there, and the 5 specific ones that are part of the REST architectural style, if your application meets those requirements, then it would be considered RESTful. And so when we're making HTTP GET requests to get a web page, right, that's RESTful. When we make an HTTP post or a put or a patch or a delete, those things are all considered to be RESTful. I'm going to show you examples of all of that in Postman. I'm going to show you well, I think, what do I have set up? I've got the GET, the put, the patch, and then or the post, and I think I have the delete. And so I'll show you that in an API server that I'm running, that I created with Python and Flask. And so it just represents a post office, right? And so the HTTP methods, right? And if we scoot down a little bit further here, we'll talk about the URI and the URL, right? And so this is what makes up your URI. Now remember, all URLs are URIs, but not all URIs are considered URLs. And so I'll give you an analogy here, right? If you think of a URL like, I guess like a Walmart, right? So like a URL would be like www.walmart.com, and that gets you into Walmart, right? So that's your URL. Or www.target.com. That gets you into the Target, okay? The URI would be something that identifies a resource that is inside of Target or is inside of Walmart. So an example of that would be down here, and I guess we'll pull this up, and I love this, is a great graphic. This is one of my favorite graphics, right? So, and this is what makes up the URI, right? You've got a scheme of some kind. It's either HTTP or HTTPS. And then you have the authority, and you can think of the authority as just the address, right? And it's going to be here, they're showing localhost 8080, but it could be www.cisco.com, .aacc.edu. And then you have the path, right? So this is taking us down to V1 books. And what you'll be seeing is on the dev ASC virtual machine, there is also an API server. They simulate a school library. The one that I have simulates a post office, or I'm sorry, a package tracking system. And then you've got the query, right? And very important to remember here that the question mark delineates where the path stops and where the query begins. Now, you don't always have to have a query, right? But that question mark is the delineator there as to that's where your path is going to end, and then the query is going to pick up, and they're querying for DevNet, right? So this is considered a URI because it's asking for a specific resource, right? It's asking for something in the Target. It's asking for something in the Walmart, as opposed to a URL, which is like, welcome to Walmart, welcome to Target, right? So hopefully that analogy resonates with you guys and makes sense with respect to, the semantics between the URL and the URI. Now, even when I'm recording my videos, I try to stick with one or the other, right? Depending on what it is we're talking about. But at the end of the day, people are going to use both. People are mostly probably going to use URL, right? Because that's what you hear all the time, especially people that are non-technical. They're not going to have any idea what a URI is. They're going to know it's a URL. But just know that in the context of our conversations here, and when we're talking about trying to get a specific resource of some kind, not the main store, we want something in the store, that's going to be a URI, right? All right, so let's take a look at a couple of examples here. And so the first example I'm going to start with is over here. And you can see that we've got, and actually, this isn't actually running on 8080. So this is just running on port 80. And this is the library.demo.local. And so there is an activity that you can do that's a lab that goes over the Postman application that will look at this interface here. And I don't believe that activity is assigned. There is no assignment for that. And I'm going to talk with Mary because I think it would definitely add some value because it's a really good assignment. So here we are, and you can see that I've actually done a bunch of demos here and added in a whole bunch of different books. But they've got some API documentation that we can take a look at, right? So how do we interface with this API? Like, how would we interface with the MapQuest API? How does that work? So let's come over here and we'll say, click here for API docs. And you can see they've got a very, very cool layout here for theirs. And this is the school library API. So you can see the HTTP methods, or they're also commonly referred to as HTTP verbs, right? Because like a verb is an action. So get, post, put, delete. Now you'll notice there's no patch here, right? And I'll talk about the similarities and differences between put, post, and patch, because that always causes a little bit of confusion. But you can see here that we've got these different HTTP methods. And this is the documentation that would explain to me, right? If let's say I'm a programmer, I'm trying to create an application that will work with this school library, the school library API, because I'm interested in, finding out what books the library has, right? So if I clicked on books, you can see that it's going to show me the parameters, right? And so I can see here, oh, okay, so you can include an ISBN and the default is false. So that must mean that by default, if I do a GET request to this API server here, that it's not going to give me the ISBN number by default. I would have to set that parameter. And then sort by, the default is by ID, but what are the available things I could sort by? I could sort by title. I could sort by author. I could sort by, well, we saw I'm sorry. We could sort by ISBN, right? And we can sort by the ID, and the default is the ID. Now, I can say, get me books, but only by this author, right? And then page, and this actually threw me. I was completely forgot about this. I was doing a recording for this. I think it's the one that you guys have access to. And what this is saying is to save resources and bandwidth, larger replies. Like if you were to try to say, give me all the books, and I think I've created over 1,000 books in this library, but it's not going to show you all 1,000. It's going to break them into smaller pages with 10 records per page. And so the page parameter is used to specify the page number. So if you created 1,000 books in here and it's only showing you 10 per page, you would have 100 pages, I think, right? So you'd have about 100 pages. And so when you say page, you're not saying how many pages to show me. You're simply saying, show me page 5, show me page 800, show me page 57. So that's what that query parameter is going to do. All right, so that's a GET request. And you can see down here, there's another GET request down here that requires an ID, right? That we supply the ID. And you can always click on try it out. So if I clicked on try it out up here, you can see that we can say, okay, yeah, include the ISBN, sort by title, and so then I'll leave the rest, and then we'll say, give me page 1, right? So then you just click the little blue execute right here. And what's cool about this is it's going to show you and it might be a little bit small. Let me blow this up a little bit here, make it a little bit larger. So it's pretty cool because it gives you the curl command that you would need to run that query using curl. So let's grab this. Let's copy this. And let's go out to our CLI, which is, I'm not sure what we're doing there. Okay, let's clear that out. And then all I need to do is paste that in. And I hit enter, and there you go. And so that curl command is going to return for me the JSON data. And again, it's going to return a JSON array, which is a Python list. And that's one of the reasons JSON is so popular, especially with the Python programming language, is that the data types are seamless, right? So that's a JSON array. And what does this array consist of? Well, we've seen this before. It consists of a bunch of dictionaries. And each dictionary is simply a book. And it's got the attributes for the book. It's got the ID, the title, the author, and the ISBN as key value pairs. And the first key is ID, and the first value is the integer 18. And then its title is the next key, and centralized motivating workforce is the value, which is a string, right? So how do we know that that's a string, and how do we know that that's an integer? What do you think? So how do we know it's a string, and how do we know it's an integer? Yep, perfect, Dylan. String's got the double quotes, and so how do we know that that's an integer? Is that the integer doesn't, right? And it's a whole number. And that's how we know that that's an integer. Excellent, Dylan. So that is all that the curl command is going to give back to us. It's going to return back to us the exact same thing we saw. Wait a minute. Oh, actually, we didn't even run the request here. So hold on one second. Workspace, let's go to, I think it's 455. Yeah, the lab. And the lab, if you're interested, and again, it's a really good lab. It's not required for the class, but it's a really, really good lab, is the 455 lab. And so you can see we've got some GET requests here. And why is it going to 5004? Hold on. And this might not have, well, here, I can fix that. So let's take a look at this GET request. I'll just change it. Can't remember what I was demoing here. And what we can do is we can go right back to the school library API, and there is the GET request URL. So let me copy that. And all I need to do is drop that into Postman. I'm going to be talking a little bit more about Postman, so don't panic if you're looking at this going, wait a minute, how is this all, how does he have that set up? So if I hit enter, you can see that we get page, what was it? Page 1 of the books, right? And so it's got these books. What if I said page 11? And I think we've got 11 pages in here, or we should. Yeah, there we go. So you can see the ID 208, 213, 212, and it's just creating sort of these random book titles by random authors, organic modular superstructure. So pretty interesting, right? Profound bandwidth monitored migration. And this uses the Faker library to create these fake names and fake titles. that you'll do in 455 if you choose to take a look at it. So again, there's my scheme, right, is my HTTP. My authority or the address is right there. And then we've got the API v1 all the way down to the books, and that's going to be, and I just drew a blank on that, the path. Sorry, that's going to be, that's going to be the path. And then we've got the query after the question mark. And the query says, include the ISBN as true. And then the ampersand separates the query parameters. So if we have more than one query parameter, those are separated by the ampersand. And so hopefully you guys are able to see that. What sort of file is the books? So it could be a text file, which is probably what it is in this case. And you're just pulling the data from that JSON file that contains those books. And so it would look just like this. And so we can query into that and get that information. So again, the ampersands separate the query parameters. And so this is our library here, right? So now let me give you another example. And this is the package tracking, right? So I made this API server, and this is how you can track packages. And so you can see this is the documentation page. And so if you go to localhost, and again, I'm running this in a Flask application, a Flask Python web application. And you can see here, okay, well, the HTTP GET method. So here's an example request, is you would say GET, and then it has / packages. And if we ran that, and where are we at here? Where did it go? There it is. So if I was to run that and say HTTP localhost / 6060 / packages and hit enter, you can see that we have a list of packages here, right? So we've got the address of the package, the delivery date, the recipient, the status, and the tracking number. And so all I would need to do is reference the documentation to look at this and say, oh, okay, and so if I did that, and here's what an example response might look like. And then I could do a GET request based on the tracking number, right? So I could actually just put in the tracking number. Now, we don't even have to put it in like a query. I can just put the tracking number in here. I'd say packages, and the tracking number is what, ABC 123. So if I ran that GET request, it would give me just the package with just that tracking number. And so you're probably thinking, and hopefully you're thinking, right? Okay, well, you know what? If I could figure out how to do a website, a front-end website that you could enter that information in with, you could create a package tracking type application, right? Like when FedEx scans, or a USPS, the post service, scans their packages, that goes into a database, right? There's some databases tracking things. And so Dylan, to kind of expand, it could be inside of a database that this information is being tracked. And it's querying the database, pulling that information out. And again, for anything that would be large scale, it's definitely a database that's going to be tracking it. But for this here, it could be something, like I said, as simple as a text file that you're just adding things to. So this is how, with this API server, you can interface with it to get the information for certain things. And now we've got, I put one in here specifically, 8675309, right? And then we get the data back, and here is a JSON object, which is simply just a Python dictionary that we could then parse to pull the information out. And you can see right here, I have status label created, right? How many times have you received an email saying, hey, you know, your package is ready to be delivered, or was just dropped off or whatever, and you go in to look to get the tracking information, and it gives you no tracking information whatsoever. It simply says label created, right? So it means somebody created the label. It's still sitting at the manufacturer or the person you bought it from, or whatever the case may be. So that's the first type of GET request. This next GET request here, oh, sorry. Yeah, this is not, let me switch workspaces here real quick. Yeah. So how would I get like the docs page? So the document page is at the root of this website. So if all you do is go to http localhost:6060 and I click send, I'm sending an HTTP GET request, just like when you're in your browser and you type in google.com. And you can see here, the status is 200. And definitely if you're taking the exam, I highly recommend that you focus on the return codes, because that's going to be at least 2 to 3 questions. And no, they're not going to ask you about 404 and 200 because everybody knows those, right? So it's going to be some obscure 400 codes, some obscure 500 code. And the 400 codes are the client codes and the 500 codes are the server-side codes. But they'll ask you for some obscure 400 code that was barely referenced in the reading, right? Or in the entire course. So definitely be aware of that if you're going to sit for the exam. So you get your HTTP status code here. And again, Postman's cool because unlike Python, and again, you can get this information with Python, it's just a little bit more difficult. But you can see it's, 10 milliseconds and 4.9 kilobytes. So I run the GET request, I click send, and you can see, what am I getting back? Well, I sent the HTTP request to get the documents HTML page. So what does it return to me? It returns HTML, right? That's what we would anticipate we're going to get back. If we're trying to query a package, and irrespective of how we query the package, if we query the package by the tracking number, we're going to get back JSON data, right? So that is a GET request, right? The GET requests are super simple. And I think this is, get all the packages. So you could get all the packages. I click that and you can see here's all the packages. And then get a specific package was, we just put in the tracking number. I click send and there it is, right? So now let's talk about a post request, right? So that's the GET request. Now we're going to talk about a post request. And a post request is when we want to put in, and that says, did I not change the name on this? Post new book. It should be post new package. Sorry about that. All right. So if I wanted to post a new package, right? Let's say my little scanner thing just scanned the package and we want to put a new package in. Well, I would send that information in the body of my post request. I would send in JSON data, right? Which is a Python dictionary. So, and I'll manually queue something up here. So we'll say, LMN and then 987654, or actually we'll just do 123. We'll say LMN 123, right? And let's say this is going to go to somebody else. And that dude lives at 2444 some way. All right. So I now have my JSON object. And so if I want to post this information, I would click send. And you can see it sending the request. And what is the code we get back? Again, very key here. The post request that sends it in, it's not a 200 that I get back saying, yeah, the GET request was good. It's a 201. The server's responding to you, telling you, hey, something was created. And you can see here what was created, right? So if I was to go say get packages and click on send, we should now see in here our last package is that one right there. So the status is pending, the delivery date is blank because it hasn't been delivered, right? We just entered it into the system. So what if I want to update something in there, right? So you can see it's pending. So what if the label gets created? Well, for that, I can do what's called a put request. And so I created 3 different put requests that we're going to be able to look at here. You've got OFD, which is out for delivery. You've got delayed. You've got label created, right? So let's take a look at delayed. So how would I set that? Well, let's take a look at the body, and that's it. This is all I'm sending in with my put request, which is just changing one thing in the package I just created, which is, package LMN123, right? So I'm sending a put request into the API server, and I'm telling it, hey, I want you to update the status, and just the status. You're not going to touch anything else. You're just going to update the record for the status. And I'm going to click send. And I must have put in the wrong, was it LMN? LMN 123, LMN 123, 6060 package. And hold on, did I get that right? Oh, packages, my apologies. Packages, there we go. Okay, so I click send, and actually, hold on a second, let's go back there. I love to call these, this is like I call these fortuitous failures, right? So I do this, make the mistake, and so there is your 404 error, right? Not found. The requested resource could not be found, and everybody has seen a 404 error. They're all over the internet when you're trying to go to things. So yeah, I can tell you right now, you are not going to get asked about a 404 error on the exam. They pick some obscure 400 series error, 500 series error. All right, so, but this is what we get back, right? This comes back, document not found, requested URL was not on the server. So then we fix our put request, right? And again, this is a RESTful request, because all of this HTTP stuff that we're doing falls and meets the criteria of the REST architecture. So I click send, and there we go. And so you can see that the delivery date is still blank because it hasn't been delivered, right? It says delayed. Recipient is some dude, here's his address. And we could have put, obviously that's not the complete address. I could have put the complete address in there, I just didn't. And then we've still got our tracking number. And so again, you start to think of this, it's like, well, if I could just figure out how to do like a website that would make, send this data in, like if someone entered in the package, the details for the package into a form on the web page, and then sends it off with a put request or a post request, or you're trying to get the information, like someone says, what's the status of my package? Like when you go out to FedEx.com, they give you a tracking number, right? And you go to their web page and there's a box that you paste the tracking number into. And what do you think that's doing? That's doing an HTTP GET, and it's using as one of the query parameters that tracking number. And it's going to try to get that track. It's going to get information on that tracking number, and it gets it out of the FedEx database. And I can only imagine how big their database is, because you've seen like how long the tracking numbers are. I mean, they're almost, I think they're like 20 some odd characters long, and it's alphanumeric with uppercase letters and 1 through 9 so almost an unlimited number of possibilities there, right? So again, at a basic level, this is what these post, put, and get requests do. So let's take a look at another one. So let's go ahead and say, so it says delayed, so let's do label created. So in order for me to do that, I just need to pull this back right here and say LMN and 123. And so let's send that put request in there to update the status to label created. Simple as that. Let me ask you this. I want to update the address. I want to put the full address of this individual, some dude. What would I need to do? What would the JSON data look like if I wanted to update the address? And we'll say that he's in Annapolis, Maryland, and I think it's 21401 there. So what would that JSON object look like that I would put here in the body to update things? I'll give you guys a second to go ahead and type in your answers there and drop it into the chat. And again, if that's how I update the status, how would I simply update the address? And even if you have to guess, you can give it a guess. Anybody? Are you guys still there? I didn't lose everybody, did I? All right. Yeah, Christy, excellent. And again, we want to put that they're in Annapolis, Maryland. So let me go ahead and change this to address. And we're going to put this out here. And so you're absolutely right. We would say 2444, oops, sorry, 2444, some way, comma, Annapolis, Maryland, 21401, right? And so if when they fill a little web form out and they want to update their delivery address for whatever, whatever the case may be, this would be what the web form would send in JSON format to the API server with a post request to update that address. So let's go ahead and send that in. And there you go. And so we just updated the address. So now let me ask you this. If we can update the address, can I update two things at one time? Well, yeah, remember, we're inside of the JSON object here. So what's going to happen if I change the status? And remember, these are just key value pairs. And we'll change the status to out for delivery. And I think I just say out for delivery, right? So sometimes you'll check to see where's my package at, and it says it's on the truck, out for delivery. So let's go ahead and click, oops, sorry, forgot the comma there. So we'll drop the comma in, again, to separate the elements of the dictionary, the key value pairs in the dictionary, and I will click send. And take a look. The address, well, the address is already updated, but I've got out for delivery. And so with the put request, if the value is already there, it just ignores the fact that, yeah, no, that's the values, that's the value. And we've got out for delivery with respect to the status, right? So what if I change this zip code to 21409, which I still think is in the Annapolis area, maybe out by Broadneck. And there we go. It updated the address and out for delivery just stayed the same. So that would be a put request. And so typically with the put request, it's when we're making changes to the element, but we don't have to provide, or I should say changes to the object, but we don't have to provide every single field in the object, right? We're just saying update the status, update the delivery date, update the address. And so we would use a put request for that. When I want to create a new package for delivery, that's when I would either put in all of the fields or all of the fields will be reflected when that object gets created. Excuse me. And then you have the get request, which again is just getting things for us. So let me pull these up here. So now I save the delete, the best for last, right? Because now we can delete packages out of the system. And to do that, let's fly back over here. And you can see, again, here's the little documentation page. I've got some HTML, some CSS. And the delete, I think, is all the way at the bottom. Yeah, so here's our delete request, right? So to get a delete, right, to send a delete request in, to remove the package from the database or from the file, whatever the case may be, you can see we've got packages and then ABC 123. And that's just an example of how you would remove the package. And the reply that you would get back, or an example response that you could get back, is message package ABC123 successfully deleted. So this is a good segue into Postman, and we're making good time here. And this is going to take us right up to the break. So Postman is a phenomenal free application, right? 100% free. You get it for Windows, Mac, Linux. As you can see here, run on Linux over here. I'm running it on my iMac. And the beauty of, oh, an update's been downloaded. The beauty of Postman is it allows you to sort of organize and curate all of your API work. And you can do that in something called workspaces. And then inside of a workspace, you can create collections. And in those collections, you put your requests. So let me give you an example of what I'm talking about. To do this, if you open Postman up, you need to log in, right? Now, when you do the lab specifically tells you that you don't need to log in to do the lab, and you don't, right? In order to get access to the workspaces, which is something that you definitely want if you're going to be, create a bunch of API type testing things, is you want to just sign up. It's a free account, right? So you just sign up with your email, create an account, you get logged in, you can get workspaces. And so take a look at this, right? So this is syncing, by the way. So I'm logged in on the DevASC virtual machine, and I have a post office workspace. And as you can see, I'm now on my iMac, and all of that work is here, including the label created that we just did. Now, remember, this won't work if I run it on my iMac, because my iMac is not, you can see here, error, connection refused. It has no clue what's going on, right? So again, remember where you're at. But the cool thing is that maybe I wanted to, pull up, like, how did I do the out for delivery again? What did the body look like there, right? Oh yeah, okay, status out for delivery. That's what I would do, right? So it allows you to see all of your work across the different platforms, and it syncs up. So if you had this on Windows and on your Mac and on your DevASC virtual machine, and you have an account and you log in and you're creating workspaces and you're creating collections and you're creating, API calls, it's going to keep all of that stuff synchronized for you, right? And that's all free. And the beauty of Postman, in addition to that, is that you can go back and look these things up. It's a lot easier than if you're having to create something maybe in Python, right? If you're constantly having to write Python code to test out things really quickly, Postman is a great alternative, and it is by far one of the most popular packages for API work. So you create your free account, you get logged in. So let me come into Workspaces, and you can see here, I've got instructional DevNet, YouTube videos, all this great stuff. So let's create a new workspace. And the workspace name here is just going to be, let's say that I teach at University of Maryland Global Campus, where I taught for about 5 years. And this would be all my API work for UMGC. Now, I can make this a team repository of all my stuff so that I can invite team members who also have accounts. Partner is new. Public is everybody could see. And personal would be just me. So we'll go personal. I create workspace. And again, it's allowing me to organize all of my API work. So now if I wanted to transition real quick, like, oh yeah, well, what are we doing? AACC, what am I doing here? And so let me take a look at what I've created, and okay, all my practice requests here, right? MapQuest, let's see what we're going to do here. Yeah, this is the MapQuest test. And so then I could run this and see, okay, what am I going to get? Oh, and the API key is bogus, so I got to fix that. So you can organize things via workspaces. So one idea or one thought would be, if you are in a development environment, you could create a workspace called Dev. You could create another one called Test and another one called Production, right? Where you're developing stuff, then you're testing that stuff, and then you're in production. So you could go through sort of a, it's not CI/CD, but it would just be kind of like a methodology for you to follow to deploy whatever it is, the application you're working on. So we come back to UMGC, and you can see it auto-magically prompts me right away, hey, do you want to create a collection? So sure, yeah, okay, well, all my API work here, let's say that the class that I'm teaching there is, and man, I can't even remember the course numbers. So let's just say it's, UMGC 001 is the course, right? So I'm going to create a collection for that specific course. So now I've got a collection, and then immediately it wants to know, hey, do you want to create some requests? So maybe for this course, I want to create just a whole bunch of get, post, put, patch, delete requests, whatever the case may be. If you don't sign up for the account, you can't get access to the workspaces, right? And so then it kind of limits what you can do in terms of organizing. So let's step back over here. So you can see I did a get request, I did a collection for get, a collection for post, and a collection for put. So now I'm going to click new. And when I click on new, you can see, do I want to do a new request? Do I want to do a collection? What is it I'm doing here? Well, I'm going to do a collection, new collection. And we're going to call this collection delete. And again, this is just a collection of HTTP delete requests that I want to practice with. So then I just hit enter, and there we go. And when I click on that, you can see, what does it prompt me to do? Hey, do you want to add a request? Yeah, no, absolutely. I want to add a request. And it should also have, when I say, as soon as I type in H, you can see it's also saving all of these URIs and URLs that I've been working with throughout. So I'm going to delete this book right here, right? So first, let's send the thing here and let's see the book. All right, so there's the book, label created. I'm going to do it by tracking number. So that was a GET request. We need to change that to a delete request, right? And I'm going to click save. And you can see if I was to check my documentation one last time, how do we delete? We just put the path in to the tracking number for the package, and then that's going to delete it. So if I was to go back over here to Postman and click send, and again, they showed you a possible response, but what do we get back? Result true. So if the result's true, that means it deleted the book. If I do this and I totally change that tracking ID and I click send, we should see false. Or wait, uh-oh, there might be something wrong. All right, there could be something wrong with my API. I'll have to take a look at the API server, but we should see result false because, again, this book doesn't exist. It's showing that the response was sent back, but the book doesn't exist. So if I go into my GET requests and say, I'm sorry, I keep saying book, package. So when I click send, we should not see that book, and we do not. I'm just double checking here to make sure that book's not in here. All right, so got rid of the book, but on my API server, I need to take a look at my code because when I tried to delete something that's not there, I should probably get the 404 that resource wasn't found. And it should say result equal false. All right. So the Postman Lab 455 is a really good one. And again, it gives you this nice graphical user interface that you can work in. Super simple to deal with. And you get to work with the school library, the school library API and all of the code here. And again, my API doesn't produce this information. It'd be great if it did, but it doesn't. I don't think it's because it's a delete instead of a get. I think in the coding, there should be an if in there that says, if the resource isn't there, right? If that book is not there, then it should return, hey, you're trying to delete some package that doesn't exist, is what I ideally would want it to do. But I don't think I put that code in there when I created it. So, but that's a good point, Dylan. All right. So they've got all kinds of different things you can do here. Now, one of the things they do in this lab is you get to log in via BASIC, and you actually generate a token, right? And so this will generate a token for you, and you get to log in. And right down here, you can see it actually generates this token. The Cisco API is way more complex than mine. You can see it's going to generate this token here, and you're going to use that token throughout the lab to sort of authorize, or I should say authenticate you for the request that you're going to make. All right, so that's Postman, and that's really this is a good breaking point right here. So what are the questions you guys have about our material so far, right? Remember, REST is just a framework. HTTP happens to fall within that framework. And so it's so convenient to use the HTTP methods in order to interface with API servers. And so what we'll do after we come back from the break is we're going to start to take a look now at the data that we're getting back, and specifically the JSON data. And I know we've looked at this, but again, it can't hurt to hear it again. with respect to we'll look at the MapQuest API, how we would parse through that data, and what are some of the things that you're going to see, because that 492 lab that you guys are working on this week, if your group opted for option 1, that is the program that you're going to want to make sure you have fully functioning by the end of 492, because it's that you extend the functionality of for your group project. All right, what questions do you guys have? Any questions? No questions. Nobody has any questions? All right. So if there's no questions, okay, good. If there's, hopefully that means that I'm explaining things. In what lab will be extended the API's functionality? So that's the group project, Dylan, and that'll be this right here. So 492 is what you guys are doing this week. And so this is individually, everybody is doing 492 on their own, which is this lab right here. And I'm going to actually walk through every step of this lab this evening so that everybody understands what's required. And then 494 is the project activity where, if your group opted for option 1, you will take a copy of somebody's 492 lab, whoever has the the best laid out lab, and you are supposed to put that up into the Scrum leader's GitHub repo, and then everybody would clone that repository to their local dev ASC virtual machine, and everybody should have something to do in that file. So, maybe you're going to add in, I don't know, I'm trying to think. Maybe you're going to add in, I'm trying to think of some of the things we talked about adding in. So whatever the features are that you were going to add in, you would work on your little section of the code, and then you would commit it locally, and then you would push that up to the GitHub repo, right? And so every time you go to work on the file, you would work on it, you would push your changes up to, origin master, and you'd push that up to the remote master on the GitHub repo. And then when you go to work, if you wanted to work on it again, like maybe you weren't happy with it, you would, again, update the local repository with a fetch, or you could just reclone what's there and get the latest and greatest. And then you work on it, commit it locally, and then push it back up to the GitHub repo. And so everybody's kind of working on the same file, but everybody's got like a little piece that they're going to be working on. And so that's going to be the 494 project activity. So hopefully that answers your question. So that's why 492, and that's why I keep stressing this, is super, super important. Because 494, if nobody in your group gets 492 and no one has that done, it's going to make 494 like impossible. Because not only do you guys have to figure out, well, what's not working? Why is it not working to begin with, 492? How are we going to get it working? And then how are we going to start adding a whole bunch of stuff into it, right, to increase the functionality? All right. So it is 8 o'clock. We're going to take a 10-minute bio and snack break and a little stretch break. And we will come back at 8:10. So I will see everybody at 8:10. I'm trying to pause here, but it will not pull. There it goes. Okay. I will see you guys at 8:10. All right. So we are back from break. And the one thing I glossed over was the put, patch, and post, and the differences between the three. So I'm going to give you a really good example of the similarities and differences. The text kind of just says, one's for. In fact, let me go ahead and pull up the text here real quick. Where are we at? No, not responses. I think it's requests. Let's see if I can find it here. Yeah, here we go. So it gives you a nice little graphic here, right? So post, create a new object or resource. Get is read. So get's easy, right? Delete is easy. Get and delete are obvious. So put, patch, and post always cause a little bit of confusion. So let me read something to you here. So The put method is typically used to update or replace an entire resource on the server. For example, if you wanted to update a user's profile information, you would use the put method to send the updated data to the server, right? Patch, on the other hand, is similar to put, but it's used to make partial updates to a resource. So, for example, if you wanted to update just the user's email address or their home address, you could use patch, right? Now, remember, put is typically used, so it depends on the implementation of it, but it's typically that's what it would be used for. So patch would be, as it says here, update some of the details, whereas put is replace or update an existing resource. So if the implementation for put would be, yeah, I'm going to update something, but I have to send in all of the data that makes up that resource with whatever part of that data I'm updating. And then post is typically used to create a new object or resource. For example, if you wanted to create a new user account, you would use the post method, right? So that's the difference between those three. And that always seems to cause a little confusion when they start talking about put, patch, and post. All right, let's dive in to MapQuest and what we're going to be working on here this week. And I'm just going to pop this tab up here, and you're going to go to developer.mapquest.com. Now, let me go ahead and log out here. So I'm at mapquest.developer.com. You're definitely going to want to sign. You got to sign in, create an account, and then you would log in. I'll put my login information in here. And there we go. Now, one of the most important things is you want to, and sometimes you're going to see this error, and it's, oh, I'm sorry. Yeah, sometimes you're going to see this error here. And it's funny because sometimes I get it and sometimes I don't. If you get the error, just continue to log in and check and refresh, because you want to manage your keys, right? And you want to generate a new key. So let's see if it lets me generate a new key, and I'll just say AACC test key. Now, the callback URL, you do not have to put in there. And I'll click on create, and you can see network error. So something's up with MapQuest. But you want to make sure that you get in here and you generate your MapQuest key. So I'm going to show you a key that you can use that I know that I have that's actually a legitimate key. And so let's take a look at the documentation, though, because the documentation, and so we start now when you start to talk about, okay, well, what additional features could I add in? Well, the directions API, this is what we're using for Lab 492. Right? And specifically, you're going to be using the route get request. Now, the documentation's really, really good. You can get the data back in JSON or XML. You're definitely, and the lab is all about JSON, right? We don't deal a whole lot with XML. In bits and pieces, XML pops up, but JSON is the predominant data model or data representation that we'll be working with. So you go to the documentation, you go to the directions API, you go to the route get page, and right here at the top, it shows you a get request, right? So here's a sample get request that you can pull and use. You could put it into Postman. You could use it in a Python script, and the Python script's what you guys are going to be doing. But take a look here. We talk about like, oh, what additional features or functionality could I add into my program? What about getting an optimized route? Maybe you want to try to get an optimized route, or give your user the option of selecting either just a normal route versus an optimized route, versus maybe you're going to get some alternate routes. Because you notice when you go to, Google Maps, right? When I use Google Maps, sometimes I'll type in, hey, I want to go from point A to point B. And Google Maps, and here, let me pull Google Maps up real quick here. Let's see what we got going on. So if I was to pull up Google Maps, And again, sometimes I'll be describing things that maybe you're not familiar with. So if I wanted to say, I want to go to Towson, Maryland, or where's Towson, Maryland at? And then I'll put in the directions here. So we'll say Towson, and you click on directions. And I want to go from Crofton to Towson. And oh, it did it. Okay, fantastic. So the blue route, right? That's the route that Google Maps is saying, you know, hey, yeah, this is your best route. What do you think the gray route would be? An alternate route, right? So you've got an alternate route here. So if we drop back to MapQuest, here are 3 things that you could add in to your 492, or I should say it's going to be 494, your group project if you guys select the MapQuest option. So let's take a look at optimized route. How is that different? Well, let me go ahead and grab this GET request. And how can I quickly check that? Well, I could just pull Postman up, right? That's what Postman's for. And sure, let's go back. We'll go to Workspaces. I'll go to MapQuest. And this is going to be a GET request. And so what would I do to create a new GET request? You could actually just click on the plus sign right there. And it defaults out to GET. You can see if you click there, again, you get all these different things you can do. And I'm going to drop that in there. And so what I'm saying here is give me the optimized route. And you can see what the data is. It's JSON data that you pass in to say, yeah, I'm going to go from Denver to Westminster to Boulder. All right. So I'll click send. Oops, sorry. Oh, I need the API key. So hold on one second, because, yep, that key right there is a good one. So if you guys need a key to work with, I would highly recommend you get your own key. But if you need a key to work with, I'm dumping this key in the chat right now. And all I ask is that you please do not be a clown like this one clown that I had who took the key and did a while loop and basically maxed out the number of requests that I could make with this key. So again, I'm sharing it with you guys under the assumption that we're all adults and you're not going to take and abuse the key and max it out so that we can't use it. All right, so that's the key. So let me come back over here. So here's this, wait a minute. Which one? I thought that was the new. Oh, we lost the. Oh, wait, I'm sorry. The tab popped off. There we go. All right. So the key. All right. So I'm going to put my value in here for the key. There we go. And we'll click send, and that key should be good to go. And there it is, right? So now we've got this optimized data. But again, the optimized route data is almost identical to the format of the regular route, right? So you'd have to take a look in here and figure, okay, well, you know, what do I want to get out of here that would add some features or add some functionality to my current app? Okay, so that's one way to do it. And let me rename this here to optimized route. So maybe you want to do that. So I'll click save. And then you would have to incorporate your new code that does whatever you want it to do with the optimized route into your team's project. So what was the other one? Route shape. No, what do we want to do? Optimize alternate routes. So let's type get. So let's take their example here and let's go back to Postman, and I'll create a new get request. I'm going to drop this in here, and it's going to need my key in here somewhere. And I'm going to have to go get my key. And actually, I just dropped it into the optimized route. So let me see if I can bail myself out there. There we go. I want to get this key here. All right, so I'm going to grab the key. We're going to go back to the untitled one here, and I'll type in the key. It's just key and the value. And you can type in the spaces down here if you want to. And you can see it's all ready to go, right? It's got a little question mark there because there's the query string, or at least part of the query string for right now in this unsaved request. And so let's change the name here. So if you double click on this little area right here, it'll allow you to change the name, or actually I'll just click save and we can type the name in here. And then this is just going to be alternate route. and we'll put it in get requests and we'll click save. There we go. And so let me drop back over here. We'll copy that again, come back over here, we'll paste it in, and there's my key, right? So the key equals, and let me come to this one. Now I've got to snag the key again because it didn't save it. And alternate route, and now I can drop the key in here. So we'll just say key and the value. And the key is now going to be, the key is now going to be in there. Oops, it didn't put the key up there. Should have put the key in there. All right, there we go. Oh, I see what it did. Hold on, it duped the key. All right, so there we go. So now we have an alternate route. So maybe you provide turn-by-turn directions for the alternate route. Because if you've got 492 done, you're already printing turn-by-turn directions out for the preferred route. Doing the alternate route it's the same code, except maybe you have a print statement at the start. Hey, here is an alternate route if you don't like the turn-by-turn directions for the preferred route that MapQuest is going to give you, just like we saw with Google Maps, right? And so that's how you can come in here to the documentation. And again, you can kind of scroll down and start to read about things, right? What are you going to be getting out of here, right? In terms of the response and the data. Maybe you want to add a feature in that tells the user, are there any toll roads? So you could check to see if has toll road is true or if it's false. And maybe you could do it. Is there a ferry that you have to take, right? So all of these easy things that you can add in. So now let's go ahead and take a look at what that's going to look like as a Python script. And I'm going to work in VI. It's just quicker. But you are probably going to be doing it in VS Code. But again, you're saving it on the dev ASC virtual machine. So the file is still going to be there. Even if it's in your Git repository, you would just come to the CLI, and that's where you would go ahead and do your git add to move it from the working directory to the staging directory. And then you would do your git commit to move it from the staging directory into the repo, into your repository. So let me take a step back here, and we'll go into the MapQuest folder. And I know that this is all in here. All right, so I broke this down roughly as to how the lab kind of breaks down, right? So if we take a look at the first file, and we'll say *_1*. So here is lab 492. And as you can see, there's not a lot of data in here. So what are we doing in here? Well, we're importing urllib.parse. And that's a very special library that is going to have a method that's called URL encode. And we need that for this lab anyway. There's another way to do this, but this is how the lab is going to show you how to do it, is we're going to use URL encode. And all that does is it takes this dictionary and the key value pairs and turns it into the format that we append to the main URL, which is our scheme, our authority, our path, and then question mark followed by the URL encode. So what is URL encode? It's the parameters. So all URL encode is doing is it's taking the values that we provide right here that are hard-coded in, specifically API key and destination and origin, and it matches those with the parameter keywords that we need to send a MapQuest. That's it. That's all it's doing. So my API key value, here's my variable, and there's the API key. My from, right? Where's my origin? Here's my origin variable and the value, Crofton, Maryland. The to, which is destination's the variable name. So there's the variable destination and Santa Rosa, California. And so then we have the main URL, which is HTTPS. There's our scheme, the authority, the path all the way down to the route, and then the question mark, which says right here is where we start the parameters. And all URL encode is doing is putting those parameters into the format that you saw right here in Postman, right there. There's the key, and actually it's a lot longer than that, but there it is, key equal, and then the key. And then it's going to, URL encode is going to put the ampersand in there for us, and then put the from, and equal to whatever we said the origin is going to be. And then an ampersand, because we're putting another parameter in there. And then the to, and equals. What did we put in there for that? And you can see here, routes equal to, remember, this was the alternate route. So it gives you 2 routes, not just the one, right? But again, all URL, sorry, I hate when I do that. All URL encode is doing is putting those little query parameters into the format with the ampersand separating each one, and the equal sign for key equal the API key, and from equals the origin, and to equal. That's all URL encode is doing. That's it, right? So what do we do at the very end? I print the URL out, right? And you can see that all I'm doing is printing out this URL, and actually, and you'll see me sometimes, I should probably do it here because this bugs me. So sometimes you'll see me call it URI, right? And again, technically that's a URI because we're going down to specific resources. And then I'm going to have to change it here. So we'll change it over here. All right. So the URI takes the main URL and appends with the plus sign this URL encode, right? And then we're going to get the JSON data, right? So I'm creating a variable called JSON data because we know what MapQuest is going to give us back. It's going to give us back JSON data. And so how do I get the JSON? Well, I tell the requests module, right? That requests for HTTP module. I tell it, hey, do a get method on that on the URI variable, which is what? It's my whole MapQuest, the get request query string, right? So I say do a get on that, and that is the requests HTTP library has a JSON function that I can put at the very end, telling MapQuest I want it in JSON format. I'm gonna convert it to JSON format, right? And really, it's going to create a Python dictionary is what we're doing. And so that's it. That's how easy it is to function with MapQuest here. So let's save this and let's run this. And I simply run by saying Python 3 and the name of the file. So there's all of the JSON data, right? It's all of my directions, all that cool stuff. And then somewhere up here at the very, very top, there is the URI. Whoops, forgot the H there. But that's the URI right there. And so look what URL encode does. It puts together everything that we need after the question mark, all of the query parameters. So if I was to copy that and come out here to Postman, what's going to happen when I create a new GET request? I drop in what we just saw, and you can see what Postman does, right? Look at this. There's my key, there's my from, there's my to. And so now you also see, well, wait a minute. What is this %2C? What does that represent? Well, what's between Crofton and Maryland in the string here? Whoops, in the string here. And we got to show the file. What's between Crofton and Maryland? A comma and a space, a comma and a space. And so when we look at this, we can see, oh, the %2C. So the %2 represents the comma with the space. %2C represents the comma and the space, and the plus just appends the text. So I click send in Postman, and there it is. And so way easier to look at here, right? A lot more going on here, way easier to look at. And we can even squeeze that up a little higher. And so you can see all of the information in here. So that's the first sort of iteration of what you'll be working on in 492. So the second iteration has you add some additional functionality in here, _2. Oh, and RI is not a command, so it's VI. All right. So now we've got And what did I do with the origin there? I think I might have been trying to test something here. I'm not sure what we were doing there. So put Crofton, Maryland. There we go. Okay. In fact, I'll get rid of the space between the comma between Crofton, or the comma after Crofton and Maryland. All right. So now what do we have in here? So all of the code is the same, except now, right after we do the JSON data equals, right, the request.get, we send the get request, and this is how we do that in Python using the requests library. Now I'm checking to see if JSON data.status code. Well, what is that? Well, that's just the HTTP status code that the API server is returning to me. So as just like in Postman, where we saw in the little green over to the right-hand side on the bottom area, where it said, 200, and you could mouse over and it would tell you all about the 200 code, we're checking to see, hey, did we get an HTTP 200 back? If we did, we're going to print out the GET request worked, right? So if this is true, then we print out the GET request work, because if it's a 200, it worked. Else, we raise an exception here, right? And we put in the status code that we received, which could be whatever. And I think as I was making the tutorial for you guys, I think 601 or so, it's some code, and maybe then, you know what, that's actually why I had changed the origin. So we'll take a look at that. And then what else happens here? So take a look at what I do. We take the JSON status. I'm sorry, we create the JSON status variable, and we get the info status code out of the JSON data. Because at the very, very bottom of the JSON code is the JSON status. How could we easily see that? Postman. Go all the way down here to the bottom and take a look. There's our dictionary key. Here is our value, which is a dictionary, and the first key value pair in the info dictionary is status code is the key, and 0 is the code. So we're checking to see if it was a 0. And if it is a 0, then we know that it worked. So let's run this over here. Let's go ahead and save the file here, and let's run it. And we'll say, we'll say Python 3 and asterisk underscore 2 asterisk. And what do we got here? Something's up. Oh, dictionary has no attribute status code. Oh, so we'll go in here and fix this. So what we should have seen, we get the URI, but we should have seen dictionary has no status code. And we're looking for JSON status, string JSON status. And I broke this, and now I'm trying to remember how I broke it. Yeah, status is. And that should have, and this is the error here. So it's checking the JSON status. Oh, no, I want, you know what I think the problem is here is, so the response code to get that back would be, trying to remember what I was doing with this. Would be request.get. Wait, URL. And now I'm drawing a blank. Hold on, let me check something here in, because I was messing around with these, and oops, sorry. So more asterisk underscore 3 asterisk. Print the JSON data out. Oh. So I want to just, yeah, so we'll look at this one actually. So this one actually this is, the other one has this if statement in there that won't work because it's pulling it from, trying to get it out of the HTML code. It's not going to get it. So yeah, to fix the other one, it would be the response object and then the status underscore code. So here, let's tinker with this for a second because I want to fix this. So that's the JSON data that we're going to get back. If I wanted, yeah, that should have worked. Hold on one second here. This is bothering me now. We don't want that router. I'm trying to remember where I dropped that. Yeah, so Dylan, it is JSON data info and then the status code, but this is checking on not the JSON status code. I'm trying to pull, I was pulling the HTTP GET request status code. I'm checking to see that we get the 200, and you can see this, right? So let me think this through. So, whoops, sorry. So if I go into the interactive interpreter, right? So this is fortuitous failure here. I go into the interactive interpreter, I import requests. So if I say HTTP response, and I say requests.get, and I'm just going to get, HTTP : / or HTTPS, I guess. All right, I'll do HTTP : / www.cisco.com. So what I've just done there is I've created an HTTP response object, and the object has all kinds of attributes inside of it. So if I say HTTP response like this and do a dot and hit tab twice, it's going to show me a list of the functions and the status code. Yeah, and so you can see right here, it's got the status code. So if I say HTTP response dot status underscore code, I get back 200. So the problem is I've got JSON on the end of what I actually want, which is, I just figured out the answer to my question here. So let's say control D. So we'll get out of here. So that's how you get the status code. So my problem is I was messing around with in control D. And hopefully the VM is not seized up here. It's not doing anything. All right, let me see if, nope, that's running that window. All right, well, this is odd. It's blinking, but it won't let me type anything here. Let's do control C, control there. Oh, whoa. Oh, I did not want to do that though. All right, well, we're gonna have to shut down our development server there. Okay, so if I come back out here and go into MapQuest, all right. So in order to fix that, _2*, in order to fix that, the problem is that I'm looking at the JSON data for a status code. The problem is JSON data is a Python dictionary. That's the problem. That's why this doesn't work. And I broke this as doing an example. So what I would have to do is I could do something simple like this. HTTP response is requests.get URL. And then I just simply have to change this from JSON data to HTTP response. And now that is going to work. All right, so there we go. So now let's go ahead and say Python 3 and *_2*. All right, so there it is, and fantastic. The GET request worked because the status code was a 200. Now, if I go back into that file, and I think this is what I was doing here, I'm trying to remember. If I pull all this stuff out here, and I put a bunch of junk in there, right? Actually, that request is probably still going to work. Let me see if I leave it blank. So let's leave it blank, and let's run it again and see what happens. Yeah, so the GET request worked, but take a look here. The response code that we get back is 611, right? And 611 is saying that you're missing either the from or the to, right? In terms of the error codes that we're getting back from MapQuest. So this is where you see that we're getting something other than a 0, right? Or at least, I'm sorry, in the JSON output that we get back, or from the JSON data that we're getting back from MapQuest, instead of the 0, we're getting the API GET request code of 600. API status GET request worked. Yeah, you can see there the response you get from the API GET request was 0. Here it's a 611. All right. So that's just adding in some additional features and functionality. So now let's go ahead and take a look at 4_4. And so again, the lab kind of progressively gets more difficult. You can see here that now what we're doing in the lab, again, we're importing URL lib parse because we need the URL encode. We've got our request so that we can make our GET request. We've got the main URL. We've got the API key, but now I've commented out the source and the to and the from, because we're now going to, and remember, so Christy, Dwayne, this is where indentation is going to be really important. So we're tucking all of that code that we had inside of this while loop, because this while loop is set to true, meaning it's going to run until the user says stop running by saying quit or queue. And so what do we have here? So for the origin, we're going to prompt the user now, because again, the first couple iterations of the lab, it's like, oh, okay, well, that's cool, but what a pain. There's not much usability in that if I need to go in and change the file every single time I want to change either the to or the from for my MapQuest directions, right? There's not much usability in that. So here, we're prompting the user for the input, enter your starting location or quit or queue to quit. And that's going to go into the variable origin. So if origin is equal to quit or origin is equal to the lowercase q, we break out of the while loop. And that's it. And the program's over with, right? We're done. And the same thing, maybe they enter the origin in and then they decide, oh, you know what, forget this, just queue to quit. And then they can break out of it again. But if they enter the origin in and they enter the destination in, then we're going to do, and here's, you're getting to reuse all of this code. Here's the URL lib encode, or URL lib parse .url encode method that creates all of our query parameters. Here is just a quick print thing that I have in there to say, you know, here's the URL in case you want to copy and paste it and dump it into Postman. Or you could copy and paste it and put it in Google Chrome or Chromium if you have the JSON View plugin installed. And we talked about that last week, I believe. And it's in the lab as well. So then what do? We get the JSON data in a Python dictionary format. And then what are we doing down here? Okay, and then this is where things kind of escalate. But again, they're giving you the code, right? So we've got the JSON status, and we parse the JSON data to get the status code. And then I even threw in here the copyright text, right? So here's how you would parse down to info, the dictionary info, and then the key value pair for copyright, right? The key copyright, and then it's got another key value pair for text, and then that is going to give me the copyright text. So again, if I went back over here to Postman, let's go down here and look. So info, copyright, and then text, because info's the key value pair that encompasses the copyright information. So info's the key that gives me the dictionary that contains the key value pair status code 0, and then copyright, and copyright has another dictionary as its value. And so then I just need the key in that dictionary, copyright, to give me the text, and that's it. And maybe this is an additional feature that you add in to your project, right? That you print out the copyright text, the image URL, and then maybe the alt text. That's something that you could add in, and maybe somebody tackles that while somebody else is working on the optimized route, somebody else is working on the alternate route. There are all kinds of possibilities here that are very, very low-hanging fruit in terms of level of difficulty, right? Because you're looking at the code right there. Okay, so print. we're just printing out the information here. I'm using the format method with the Python print string. And then what do? We say, if the JSON status is 0, meaning, did we get back a successful request from the API, from the MapQuest API server in our JSON data, not the HTTP value. So this is the JSON value that we're getting out of the JSON data. So if that's the case, then I'm going to print out my API status is that. My API status is, what am I doing? Oh, it's just two different ways to do it, right? Because the string, you have to typecast it to a string because that value for the status is an integer, right? If I didn't have the str here around JSON status, we get back 0. It's going to tell me you can't concatenate a string with an integer. And then I've got like a little delimiter here, and then we print out directions from, and these are just placeholders right there. Remember the open brace, close brace when we use the format method. And so then origin would be the first one and destination would be the next one. So I'm just basically saying, hey, directions to get from point A to point B. Here's your trip duration. And I kind of space it out so it's going to line up really nicely here. And then I parse the JSON data to route formatted time to get the total time. And then I parse the JSON data to get the distance in miles, route distance, and then I get it in kilometers. Now, very important, and this is something that just changed. Last semester, this worked, and MapQuest removed it. And what they removed, oh, and it looks like they might have updated it here. Ah, they finally updated it. When I did my tutorial video for you guys, it was in here. So they used to have a category, fuel used, and they've pulled it out, and they finally updated their documentation. I was surprised that it was in there when I made the tutorial, but it's no longer supported. So the lab is going to reference fuel used, and it's going to want you to produce the code to give you the fuel used in gallons and liters, but you don't have to do that because it's not in there. It's no longer supported, right? So let's run this. Let's say Python 3 *_4 *. All right, so now this is a little cooler, right? So I can say, okay, I'm going to go from Crofton, Maryland, and I want to go to Coronado, California. I'll do no space between the comma and California. All right, and so there we go. Take a look at that, right? Tells me, okay, here are your directions. It's going to take you 38 hours and 52 minutes. Total distance in miles, total distance in kilometers. And we can already see, right? Well, that's kind of funky. Maybe I only want it to 2 decimal places for each of these, and I'm going to show you how to do that. But you can see here, so the %2C plus, the plus concatenates this, right? Because there's a space between the comma, the %2C, which represents a comma, and the Maryland. But over here, you don't have to concatenate it because there's no space. So it's just %2. So the C, I'm sorry, %2C. So the %2C represents the comma, right? Okay. So, and we can run this again and again and again, or I can type in Q and say, that's it, I'm done, I quit. All right. So let's take a look at 5 and see what 5, we'll go with VI into 5 here. Whoops, VI into 5 and see what 5's got to offer. So again, all of this code at the top is the same code that we've been using over and over and over again. And oh yeah. And I think the only thing that's different in this code is this right here. So when you use, and this is the beauty of the format method with strings. So let's say I want to truncate on my floats the number of decimal, or the number of places after the decimal point. So here's how you do that. Inside of the curly braces that represent where that value would be displayed, you do : dot 2F. And that truncates it at 2 places past the decimal. So 5 is going to be an easy one to look at here. So we'll say Python 3 *_5 *. And we'll say we're going to go from We'll go from Santa Rosa, California to Coronado, California. And if you've never been to Coronado, definitely put it on your bucket list. All right, so there we go. Much shorter trip, 8 hours, 29 minutes. And I've actually made this drive in one night from Santa Rosa all the way down to Coronado. And there's your miles and your kilometers, but you'll notice, see, it's truncated, right? To 2. If you wanted 3, you would have put 3 inside that print statement. Let's take a look at number 6. VI asterisk underscore 6 asterisk. Oh, I didn't want that. It didn't save. Okay, so we'll say, do this here. All right. So here's number 6. Again, all of this code has been building up in your program, right? They take a super iterative approach here, where it's like you do some code, you get that working, then we add some more code in there, you get that working, then we add some more code in there, and you get that working. And again, this is all leading up to the project. And so it was here that they wanted you to add in all of this error checking code. But what didn't make sense to me when I was reading it, and it was probably because I was doing it on the fly, was they have you check for the JSON status here and print that information out. But then they wanted these other they wanted to do the if, else, right? So what are we checking for here? Well, we're checking to see, do we get a 402? Well, first of all, we're checking to see if the JSON status is 0, meaning, hey, everything worked great. We're going to go ahead and say it's a successful route call, and we're going to do a for loop. And this is probably the toughest thing in the lab. If you were to have to do it without, without having the code there for you, this would be pretty tough, right? So you're going to print out the turn-by-turn directions. And I know that sounds crazy, but let's break it down, right? You're just basically taking that JSON data, and for each maneuver, and all of the maneuvers sit, if you parse the data, they're here. It's route, legs, and legs actually has a list as its value. In the key value pair, it's a list. So we want the index position, not the key. Remember that. When you're you're trying to access elements in a list, it's based on the index position, not a key, right? And then we go through each of the maneuvers. So let's drill down. Let's see what this route legs 0 maneuvers. Where does that take us in the code? So if we fly all the way back up here, and you know what? This is a great opportunity here. Let me actually flop back over here. And I'm trying to remember if I have, let's see if I have it like logged in here. If I did https:// oops, map. I don't have one in here. Okay, so let me grab one out of Postman real quick. So I'm just going to grab a GET request here out of Postman for MapQuest, and I'm praying that we have a legit key, and we'll grab optimized route. All right. So if I copy this and I put it into Chromium, remember, definitely add the JSON view plugin, and you can see up here it says, view source, right? So this sort of prettifies the JSON output. So, okay, so here's the top key value pair in this JSON object, which is a Python dictionary. So it's route. So that's why the first bracket, double quotes route. Okay, so that gets me this dictionary, and you can see this dictionary is massive. So after route, I have legs, because in the dictionary that is the value to the key route, there is another key value pair, which is legs. But legs doesn't point to a dictionary. The value of legs is not a dictionary. It's got the open bracket, not the curly brace. The open bracket is a Python list or a JSON array. And so that's why we would say brackets, double quotes, route, double quotes, bracket, and then legs. And then we want index 0. And index 0 is the first element in this list. And what is the first element in the list? Well, lo and behold, it just happens to be, and I'm trying to highlight, let me highlight, a dictionary. And so we go from dealing with a dictionary to a key to a list, and now we're back to a dictionary here. And so now when we're inside this dictionary, you can see that we've got maneuvers. And so now we go down to another key value pair. And maneuvers also points to a list. And that list is every maneuver for your trip. Index 0, index 1, index 2, index 3. And each of these little key value pairs for the index is a maneuver. But each maneuver is captured inside of the dictionary. And so if we go back over here to, wait, where was I at there? I think I want to be back over here. Sorry about that. Yeah, so we come back here, we use the key route to get the value, which is that huge dictionary. And then inside that dictionary, we use the key legs because we need to get the list, the first element of that list, which is another dictionary, which is maneuvers. And so we use the maneuvers key to get the access to its value, which is a list. And the list are turn-by-turn directions. And so we iterate over every maneuver in the maneuvers list. That's the value for the maneuvers key. And we simply print out the name of the maneuver along with the narrative, which says, turn right on H Street, turn left on Highway 80, right? Get on 695, merge into Glen Burnie, whatever the case may be. And we concatenate that with some other information here. And we format out and we get the distance for that, right? Like, it's a go 6 miles and then exit 55 on the Jersey Turnpike or whatever, right? So if the JSON status is 0, we do really what's the hardest thing in the lab, which is going to be this for loop. If it's not 0, we want to check to see, okay, well, wait, was it invalid input for one of the locations, which would give me a 402? And if it's not invalid input, right? So if it's not 0, maybe it's 402. If it's not 402, maybe it's 611. And we saw 611, and that was invalid input for one or both of the locations, right? So you probably see the same thing for the 402. I don't think I could get the 402. But anyway, and then it gives you the response back. So let's run this. Let's see what we get. And we want to do this, and come on back. And we want to do this right here. So we'll say Python 3. All right, so I'm going to go from Crofton, Maryland to Coronado, California. So there's my URL. There are all of my turn-by-turn directions. And the status code, if I come back up here, API successful, right? And you saw that I broke it before, so let's break it again. So let's VI this. Let's go to the top. Let's break the, oh, you know what? To break it, all I have to do is rerun it. I was thinking we had to change it. So all I have to do, I'm just going to hit enter. And then I'll put, oops, sorry, Crofton, Maryland. And take a look at that. Status code 611 was returned. Invalid user input for one or both locations because I left out one of the locations. In fact, what if I did, I'm curious if I do this, if that gives me the 402. Did we get a, yeah, there we go. Okay, so if you don't put anything in there, you're going to get a 611. If you put some bogus location in, you get the 402, right? So then you just saw how you could check for that. Maybe one of the people in your group extends the functionality here and goes out and looks up the rest of the error codes, and maybe their job is to do the if, elif, and do elifs for a bunch of the error codes. That would extend the functionality of this, right? So if you've been paying attention tonight, I've given you at least a half dozen things that you could do to extend the functionality out of this program. And I think 6 was it. I think the timing's pretty good here. So we've got 9:01 and yeah, 7. I don't even know what 7 was doing here. Hold on. Kind of lost track at one point of how many copies I had. Yeah, it's the same thing. Okay. So that, I mean, that's it. That is the entire 492 project right there, which then you guys take, extend the features and functionality of that project, and boom, you got 494 and you're done, right? All right. So is this helping you guys? Are you guys, is this making sense? Are the lectures helpful? Am I over the target here, as they like to say in the military? So I'm looking for your guys' feedback here. Does this make sense? Do you have a better understanding of things now?
Oh, this definitely helps me out.
Okay.
You know, kind of seeing this beforehand. And I know like when I'm doing the labs, your videos are definitely, you know, when I get stuck or something, definitely, you know, good to go back to the video and see, you know, what I'm typing wrong or, you know, or, you know, whatever. But
Or
yeah,
see what I'm typing wrong.
well, nah, usually it's me. Like the other day, at one point in the lab, they had us move like the RE ret valve or ret valve with the double
Yeah, the
brackets.
return value. Yeah, yeah, and the inner
Yeah, they
function.
had us move it before the define JSON, and I left it there, not realizing because it said you could do this, but it wasn't a good idea. Or,
Right.
but I never put it. And once I put it back, then everything worked. You know, I was able to finish the lab. So, you know, it definitely helps me out.
Okay,
So
excellent. All right. So anybody else have any other questions before we bust out of here for the night? And yeah, and believe me, once you guys start digging into the lab, take it slow. Again, like you saw me break it down into like 7 different files. So literally I would just create one file and do the first part that they ask you to do in the lab. And then copy that, just give it a different name, and then open that up and then work on that. That way I know that my one file, the first file I did work. Now I'm focused on the second file and adding some functionality in, and just take it slow. And again, like I said, the video will walk you step by step through. And that is it. That's all I have for tonight, guys. So unless anybody has anything else, I will kill the recording here.